We are given two straight lines 1 plus p into x minus py plus p into 1 plus p equals to 0, 1 plus q into x minus qy plus q into 1 plus q equals to 0, and the third straight line is y equals to 0, that is x-axis. Right, these two straight lines, the first one and second one, are making a triangle with x-axis. Now what exactly happens to the orthocenter of this triangle? That is the question. Right. Now, if you closely observe, these two straight lines have some similarity. P is replaced with Q, otherwise, everything else is same. 1 plus P, 1 plus Q, minus Py, minus Qy, P into 1 plus P, Q into 1 plus Q. Very good. So, there is some similarity with these two straight lines, and they are making a triangle with x axis. Right. Now, if you closely observe this one, what is the x intercept and y intercept of this straight line? X-intercept is when we input y equals to 0, then x becomes minus of p into 1 plus p by 1 plus p. That is x-intercept is minus p, right? X-intercept becomes when we make y equals to 0, minus of p into 1 plus p by 1 plus p, which is minus p. Similarly, y-intercept will become what? When we make x equals to 0, py equals to p into 1 plus p, so y equals p into 1 plus p by p, which is equal to p plus 1 or 1 plus p. What does that mean? The x-intercept and y-intercepts are minus p and p plus 1. What does that mean? Um, when p is, let's say when p is 3, x-intercept is minus 3, y-intercept is 4. When p is 2, x-intercept minus 2, y-intercept is 3. That means minus 2 comma 0 and 0 comma 3, this point, right? The 2 points x-intercept and y-intercept. Similarly, my x-intercept minus 1, y-intercept 2, likewise, right? Let us, and both straight lines more or less will look similar depending on how p is varying and q is varying. First, let us try to understand geometrically what exactly, uh, how exactly is this orthocenter behaving. After that, we'll try to find algebraically how to get what exactly is the locus, whether it is hyperbola, ellipse, parabola, or straight line. Right. First, let us try to understand this thing geometrically. How exactly is this locus behaving? Let us try to draw both the lines and see what exactly is happening with this with its orthocenter. Right. Now, if you see in this triangle, if you see there is this line, this blue line. What is this blue line? Blue line is actually the same line where the intercept is minus 6 and plus 7. We just discussed, right? Minus 6 and plus 7, minus 5 and plus 6, whatever. So this blue line is the equation of this line 1 plus p into x minus p by plus p into 1 plus p. When, when p is what? Uh, when p is 6, right? X intercept is minus 6, y intercept is p plus 1, that is 6 plus 1, that is 7. Similarly, when p is 7, this line will move like this. X intercept is minus 7, y intercept is 8. Similarly, when p is 2, x intercept is minus 2, y intercept is 3. When p is minus 2, right? When p is, let's say, minus 3, then x intercept is minus x-intercept is minus of minus 3, right? Minus of minus 3 is plus 3, and y-intercept is minus 3 plus 1. This is minus 2, right? Similarly, when p is minus 5, x-intercept will be plus 5, and y-intercept will be minus 5 p plus 1. That is minus 5 plus 1, which is minus 4. So basically, this line p is moving like this. The line p is moving like this, right? This line P is moving like this. Similarly, the line Q also is exactly the same. So we can make Q also move like this. This when Q is moving, this green line is actually the other equation, right? So while P is moving, this line will also move. Let P is the first line is moving like this, and the second line will also move like this, right? Now, while both lines are moving, a triangle is getting formed, right? A triangle is getting formed. Now let us take one simple case where P is equal to Okay, a sample triangle like this. When P is when P is 4, x-intercept is -4 and y-intercept is 5. Similarly, when Q is 1, x-intercept is -1, y-intercept is 2. Right? P plus Q, the equation in P, equation in Q, when P equals to 4 and when Q equals to 1. Now let us look at this triangle. These two lines should make a triangle with x-axis. Right? So obviously we want to find orthocenter. Orthocenter means perpendiculars drawn from each vertex to the opposite side, and this line is on x-axis. AB is always on x-axis. What does that mean? The perpendicular will always, from point C to AB, will always be parallel to y-axis, right? Will always be parallel to y-axis, and we'll draw it like this. And at the same time, the perpendicular from B to AC, that is this one, that is this pink line, and the perpendicular from uh, C to AB we have drawn, and B to AC is we have drawn, and A to BC, that is this line, that is this pink line, and these three perpendiculars are meeting at this point D, which is the orthocenter. Now, how is D moving? As we vary this P or this Q. Okay, let us try to vary this P. Then, if we vary this P, this line will keep moving. At the same time, this line orthocenter is moving. You can see this line orthocenter is moving this line along this line, this pink dotted line, right? You can see this, right? The animation. When the line involved P is moving, the triangle is changing. The shaded area is this triangle. This triangle is changing, but the center is moving across along this line, right? The area of this triangle or the size of this triangle is changing while P is changing, and the center is moving across the same line. Similarly, when we make the other line also move, the green line, which is the line involved with Q, then also when that line is also moving, the triangle is changing. Still, the center still is across this line only. Center is still center is still going across this line only. Still across this line, right? So center is actually moving. The locus of the center is actually a straight line. Now, how do we prove this algebraically? Let us go back and see how do we prove this algebraically, right? Now, to prove this algebraically, let us try to solve both the given equations, right? Now, this equation intercept we have figured out it is meeting x-axis at minus p comma 0, and this line is meeting x-axis at minus q comma 0, right? That is very clear. A and B, which are both on x-axis, and any perpendicular from C to AB will always be parallel to y-axis. That also we have figured out in the previous diagram also. Now let us try to solve both these equations and find out C, because A and B will be on x-axis and C will be somewhere, right? And the point of C, let us try to solve these two equations and get C in terms of P and Q. Right, let us take the first equation and multiply with 1 plus q. And second equation will multiply with 1 plus p. So 1 plus p into 1 plus q into x minus 1 plus q into p into y, that is this one, plus p into 1 plus p into 1 plus q equals to 0. Similarly, let us multiply the second equation with 1 plus p. 1 plus p into 1 plus q into x minus 1 plus p into q into y plus 1 plus p into 1 plus q into q. Right. Now let us subtract the second one from the first one. So these two will get cancelled. We'll be left with 1 plus p into q minus 1 plus q into p into y. That is this one. 1 plus p into q minus 1 plus q into p into y plus 1 plus p into 1 plus q into p minus q. Because 1 plus p into 1 plus q is common. 1 plus p into 1 plus q into p minus q. That is this one. So what does that mean? Here, this PQ and this PQ will get cancelled. We will be left with y into q minus p is equal to or minus of 1 plus p into 1 plus q into q minus p. That means this q minus p and this q minus p will get cancelled. So we will get y equals to 1 plus p into 1 plus q. Right. And So that is the point. Uh, that is this y 1 plus p into 1 plus q, right? And the c is always lying on on the line which is parallel to y axis, right? And if you substitute this y in one of these equations, we'll get x as pq. Right. So we got the point of c as pq and 1 plus p into 1 plus q. Fantastic. And the equation of this line, perpendicular drawn from c to AB, is always x equals to pq because that is parallel to y axis. Now, that is this equation, x equals to pq. Now, what is the second equation? We want to draw one more normal. Right. Let us try to draw a normal on this line AC from this point B. Right. What is the slope of this line AC? That is 1 plus p into 1 plus q minus 0 by pq minus of minus p. That is p into q plus 1. So this becomes the slope of AC is this 1 plus q 1 plus will get cancelled 1 plus p by p. So the slope of this normal will become minus 1 by the slope of this one, which is nothing but minus p by 1 plus p. Right, because this slope for product of these two slopes should be equal to minus 1. So the slope of bn will become minus p by 1 plus p. And this line bn should pass through this point having this slope. So y minus 0 or y minus y1 equals m into x minus x1. So y minus 0 equals this slope into x minus x1. x1 is minus q. So x plus q. Right. So what does that mean? Y into, if you simplify this, right? So this becomes uh, y equals to minus p by 1 plus p into x is again pq, right? So we are solving these two equations, this equation and this equation. In this equation c n, this equation is anyway x equal to pq. So we are trying to find what exactly is y, the meeting point of this line, the meeting point of this line and this line. So when this line, the vertical line x is anyway pq. So if you substitute this pq here, we are getting y as minus pq. So this becomes pq plus q. That is nothing but q into p plus 1. So this and this will get cancelled. Y will be equal to minus pq. So when x equals to pq, y equals to minus pq. What does it mean? X plus y should be equal to 0. So x plus y equals to 0. That is the equation of the line that we are looking for. Right. Now, when we go back and see our diagram, we can clearly see that this line x plus y, actually this line is exactly x plus y equals to 0. Right. This pink dotted line, it is actually uh, this orthocentre is actually going on this line, which is the equation that we have got algebraically as well. Right, guys? So we just solved both the equations. What we have done, we solved both the equations and found this point P and found this point C, right? PQ and 1 plus P into 1 plus Q. And this normal is always parallel to y axis, that is x equal to PQ, right? That is this normal. And then we figured out one more normal and we solved both the normals and we got this point. This point is always coming as PQ comma minus PQ. Right. And so what does that mean? X plus y equals to 0 because one coordinate is actually the negative of other coordinate. Magnitudes are same. Right, guys. So AB is always on x-axis. So that means, and this blue line and this green line we know in terms of P and Q. When we solve this, we got C as PQ and 1 plus P into 1 plus Q. Right, guys. Thank you. Hope you like this.